Hello everyone, welcome to today's lesson, which is on the Pythagorean Theorem. Today is finally, if you remember, at the beginning of this unit, I said this whole unit was about triangles. And we have done absolutely nothing with triangles so far. We've memorized our square roots, we solved some equations with square roots in them, and we've even estimated square roots. So finally today is where we see where those square roots come into play with triangles. Okay, so the Pythagorean theorem is great to help us find a missing length. So this only works for right triangles, and we'll talk about that here in a second. But what the Pythagorean theorem does, it helps us find a missing length of a right triangle. So we're going to figure out how to do that in today's lesson. And then also, if I give you three numbers, can you see if the triangle is right or not? Okay, so that's our second objective for today. Now, before we start talking about triangles, I've had some students in the past miss these questions just because they couldn't remember how to round. So let's see how well you guys remember rounding. Okay, so we're going to round these numbers. Let's do to the 10th first, and then we'll do to the nearest hundredth afterwards. All right, so 10th, if you look at this chart here, is one place after the decimal. So I only want one decimal place. So on this, I am going to look at the one decimal place, so that's the 10th spot. And then if you remember, it's either going to stay that number, so it's going to either stay 3.6, or it's going to round up to 3.7. And to know which case that is, we look at the number directly behind it, which is 8. And in terms of rounding, if it's 5 or bigger, we round up. Okay, so since this is an 8, we're going to round it up, so we'll round it to 3.7. All right, on the next number, I look at the 10th place, which is 2. I look at the one behind it, it's 5 or bigger, so we're going to round that 2 up to a 3. And this last one is kind of tricky for people. So I look at this number. I look at the one behind it. It rounds up. So rounding up would make it a 10. So I would put a 0 here, and I would have to carry that 1 over to the 7. So to the nearest 10th place is actually 8.0. Okay, so that's tenths. Let's do hundredths. So I'm going to look at hundredths. There's 2 decimal places. So I'm going to look at the second decimal place this time and look one behind. So this would be 3.6, and it either stays an 8 or rounds up to a 9. Since this was a 4, it's going to stay an 8. All right, the second one, look at your 5. Look at one number behind. It's also a 4, so it's going to stay, not 2, 5.25. And the last one, look at the 9. The one behind it was a 2. It's going to stay, so this would be 7.99. Okay, we just want to do a quick refresher of rounding before we move on. All right, so let's talk about triangles finally. So this is called the Pythagorean Theorem. I know that's always hard for people to say. It was actually discovered by somebody named Pythagoras. That was his name. So he was studying triangles, and he discovered something super special about right triangles. All right, so we're going to see what he discovered. I'm going to see if I can share this. I'm going to share a different screen. All right, so this video kind of shows it. What he does, though, we have a right angle. So it's a right triangle since there's one right angle. He took the 2 small sides and he made a square out of the sides. So this side length of the triangle, he made the same side length going as the length and as the width. So he made a full square there. He did the same thing with the other side, and he filled them with water. And when he flipped them upside down and saw how it compared to the square of the other side, he noticed this, that the 2 squares fit perfectly into the third square. And if he flipped it back over, again, it would fill perfectly. And when I say perfect, I mean exactly perfect. Not even a little difference. They were exact. And not only did it work with this triangle, he discovered that it would work with all right triangles. Okay, so then we can use that to help us now find a missing side of a triangle. So let's kind of talk about some of the basics here first. Oh, let me pause this. Sorry about that. Okay, so we have a right triangle. We have a leg. We have another leg. The biggest mistake is that people don't know what the hypotenuse is. So the hypotenuse is always the longest side of a triangle. And the hypotenuse is always across from the right angle. So if you can't tell which side is the longest, find your right angle, draw an arrow directly across from it, and that tells you what the hypotenuse is. And we're going to be labeling the sides of our triangles A, B, and C. Now, A and B can be mixed up, but C always has to be the hypotenuse, the longest side. Okay, so we're going to always label the hypotenuse C. A and B can be mixed up because they're both legs. It doesn't matter which one you call A or B. All right, so go ahead and pause the screen right now. First off, find the triangle that is not right. And then on the other two remaining triangles, I want you to put a C on the side that is the hypotenuse. So label the hypotenuse C. All right, go ahead and do this now. Okay, let's see how you did. So first off, the one that is not a right triangle is this one, the musical triangle. The other ones have right angles. Okay, so the hypotenuse is always across from that right angle. So on the first triangle, that was the hypotenuse. And on the second triangle, that side was the hypotenuse. And if you want to, you can fill in the other ones with A and B. Again, you can switch those around. A and B can be switched, but C cannot. All right, so now that we know the parts of a right triangle, let's start using that information to actually find a missing side. So here are the steps we're going to follow. First off, we have to know the formula. And if you remember from the video that we took the square of one of the legs and turned the other leg into a square, and we combined them or added them, it was equal to the square of the hypotenuse. So a squared plus b squared equals c squared is what we call the Pythagorean theorem. All right, steps. Step one, we are going to identify the sides of the triangle. Remember, the most important part is knowing which one is C. A and B can be mixed around, but C cannot. Then we're going to plug them into the formula, a squared plus b squared equals c squared. And we're going to simplify and solve that equation. Notice the last step should always be to take the square root. All right, so let's see what this looks like. We have a right triangle, we have a missing side, so we're going to discover what that missing side is. So first step is to identify the parts. C is the most important. So find your right angle, draw a line across from it, that is your C. A and B don't matter, they can be switched around. And we're going to plug into the formula a squared plus b squared equals c squared. All right, so I labeled 11 as my A. I could have done that as my B, doesn't matter. 15 was my B. Again, that could have been my A. And I don't know my C. That's what's missing. And this is kind of why we memorized our perfect squares. 11 squared is 121. 15 squared is 225. If you don't have them memorized yet, you guys can use a calculator now. Now, sometimes we're going to be adding those two measurements, and sometimes we're going to be subtracting them. So here we have a giant plus sign in between, so we are going to be adding in this case. If I add those two numbers, that would give us 346 equal to c squared. And now I take the square root of 346 because I want c, not c squared. So to undo squaring, we square root. Now, technically, this would have two answers, positive and negative square root of 346. However, I can't have a negative measurement, so I take off the negative. I'm not going to have a triangle that is negative 4 feet. It just doesn't work that way. I don't have a side length with that. So my answer, there's a few different ways you can answer this. Kind of depends on what the question is asking for. If they are asking for a radical, if you remember is a square root. So my answer as a radical would be the square root of 346. If they're asking as a decimal, that's when you type it into your calculator. That would give us 18 point. Now this says to round to the nearest hundredth. It was 601. I put 3 down because I'm looking at hundredth. So it's tenths, hundredths. I look at this place value. I look and see it. Does it stay a 0 or does it round up? In this case, it stays a 0. So 18.60 is rounded to the nearest hundredth. And finally, it could even ask me the perimeter. So the perimeter of the triangle is when I add up all 3 sides. So 11, 15, and 18.6. So 11 plus 15 plus 18.6. I'm going to use a calculator here. So 11 plus 15 plus 18.6 gives us a perimeter of 44.6. Should probably put my labels on these. We're dealing with feet. So there we have 3 different ways we can answer this. Again, it depends on what the question is asking for. The missing side as a radical is the square root of 346. The missing side as a decimal is 18.60. And the perimeter, when I add up all the sides, the perimeter of the triangle is 44.6. All right, let's try another one like that. Okay, so first find your right angle. Identify the hypotenuse. That's the missing one, so I'm going to call that C. A and B can be switched around. They don't matter in terms of order. So I'm going to plug into A squared plus B squared equals C squared here. A is 10, B is 12, and C is the missing. All right, 10 squared is 100, 12 squared is 144. When there's this big giant plus in between, we add them. So this would be 244 equals C squared. Now use common sense here because some people say 244 is their answer. But if you look at the triangle and this is 10 feet and this is 12 feet, does it make sense that the third side is 244? That doesn't make sense. It's way too big compared to the other two. So do not forget that there's a last step here. To undo squaring, we square root. Okay, and that actually is our answer as a radical, the square root of 244. I'm going to label it feet here. Now I'm going to use my calculator to type in the square root. This time it says to round to the nearest tenth. Our answer is 15.62, but tenth I went 1 decimal place, so I'm going to look behind. It's going to stay 15.6 feet. And last, if I'm trying to find the perimeter, I add up all the sides. So we have 10 plus 12 plus 15.6. Again, it's a lot easier if you use your calculator to give us an answer of 37.6 feet. All right, let's try another one here. So on the previous 2 examples, notice every time we were missing the hypotenuse. We're missing the hypotenuse. We're going to do a few examples of where we're not missing the hypotenuse, but we're missing a leg. All right, so let's start with this one. Find my right angle, draw a line across from it. That specifies the hypotenuse. So that's our C. The other 2 you can mix and match, doesn't matter. I'm going to call X my A and 4 my B. I'm going to start with my formula, A squared plus B squared equals C squared. I'm going to plug in my values. I don't know a squared, so I'm going to keep it. B is 4, and C was 9. All right, so I know my perfect squares. 4 times 4 is 16. 9 times 9 is 81. Now, this is where it's different from the other ones, because unlike the other ones, there was a big giant plus in between the other ones, whereas this one, there's not. I actually have an equation I have to solve here. The goal is to get your a squared by itself. That's our happy couple. Get rid of the outsider. So to get rid of the plus 16, I have to subtract 16. So when I'm finding the hypotenuse, I add the 2 squares, but when I'm finding a leg, we need to get smaller and subtract the 2 squares. So 81 minus 16 gives us 65. And don't forget your last step. To undo squaring, we square root. So our answer as a radical is the square root of 65 millimeters. And then when I type that into my calculator, it says to the nearest 10th. My number here was 8.06, but I went tenths, so I went 1 decimal place. I look behind it, it's a 6, 5 or bigger, round up. So this would be 8.1 millimeters. And last perimeter, we have 9 plus 4 plus 8.1. And if we add those together, we should get a perimeter of 21.1 millimeters. All right, I'm going to go ahead and post a challenge here. I'm going to ask you to find the answer to the missing side on this triangle. Go ahead, pause now, and we'll go through the answers here in just a second. All right, step 1, did you identify your hypotenuse correctly? Our C should have been 15. The other 2, you can mix and match. And delete this little kangaroo so I have more space here. All right, our formula then is a squared plus b squared equals c squared. Don't know a, b is 9, c is 15. We memorized our perfect squares for this reason. 9 squared is 81, 15 squared is 225. All right, when there's on opposite sides of the equals, this is when I need to subtract the 81. So 225 minus 81 gives me 144. And don't forget to undo squaring. We have to square root the answer, and that would give us 12. So our answer on this one should have been letter C. All right, we're going to move on to our second objective. So we already covered the first one. I can find a missing length of a right triangle. We're going to now move on to, you can determine if a triangle is right or not. All right, so if I give you any 3 random numbers, 5, 12, 14, and I ask you, is this the right triangle? What do I do? Okay, so that's the question I'm posing to you guys. So here are our steps. Step 1, we always make the biggest number C. And if you think about why, it's because that C is our hypotenuse, and our hypotenuse has to be the biggest side. So that's why we always make C the biggest. Other 2, A and B, you can kind of mix and match. We're going to plug it into our formula, a squared plus b squared equals c squared. And we're seeing, are the 2 sides of the equation equal? If they are equal, it's a right triangle. If they're not a right triangle. All right, so let's see what this looks like. So we have 8, 15, and 17. Again, I'm looking to see which one's the biggest because that has to be my C. Other 2, you can mix and match. All right, so I'm going to plug it into a squared plus b squared equals c squared. So I have 8 squared plus 15 squared. I'm seeing, does it equal 17 squared? Well, let's do the math. 8 squared is 64. 15 squared is 225. Does that equal 17 squared? Well, 17 times 17 is 289. So does 64 plus 225 equal 289? Well, you could use a calculator or you could do that by hand. 64 plus 225 is 289. If they're equal, it does make a right triangle. If this doesn't equal, they don't make a right triangle. All right, so let's try another one like that. We have 12, 9, and 10. Biggest thing you have to get right is that 12 is your C. The other two, you can mix and match. So we have A squared plus B squared. Does that equal C squared? So 9 times 9 is 81. 10 times 10 is 100. Does that equal 12 squared? 12 times 12 is 144. So let's see, 81 plus 100 is 181. Does that equal 144? No, it does not. So they do not make a right triangle, those three measurements. All right, let's try a little bit on your own. You guys can go ahead and pause now, and we'll go through the answers together. All right, let's see how you did. 10 should have been your C. The other ones, again, you can mix and match. So we should have had 6 squared plus 8 squared equals 10 squared. That's 36 plus 64. Does that equal 100? Let's see, 36 plus 64. It does equal 100. So are these a right triangle? Yes, these three measurements would make a right triangle. All right, let's try one last one here. We have 15 needs to be our C. The other two are A and B. So 10 squared plus 10 squared. Does that equal 15 squared? Well, 10 squared is 100 plus another 100. 15 squared is 225. Well, that's 200. Does not equal 225. So this would be a no. All right, hopefully you found this video helpful. There is homework tonight. Answers are all posted along with it. All right, hope to see everybody soon. Bye.